Hello again. This month, MasterTech will explore the diagnosis of selected interior electronic components. Let's start with the electronic instrument cluster. For 1986, the electronic clusters are built by two manufacturers, Huntsville and Motorola. The Motorola unit is used exclusively on Dodge Lancer and Chrysler LeBaron GTS applications. This 1986 Huntsville cluster on New Yorker applications uses vacuum fluorescent displays to show oil pressure, system voltage, speed and odometer, engine temperature, and fuel level. A new 1986 feature is the Traveler. The high-tech displays of these new clusters do not require new high-tech skills. You need more knowledge to diagnose a conventional cluster because the high-tech electronic cluster can diagnose itself. The electronic instrument cluster's self-diagnosis checks each segment and the Traveler, which will be discussed in detail later in this session. The diagnostics show you if any segments are not illuminating, indicating an open in the circuit, or if two or more segments illuminate at the same time, indicating a short. If either problem exists, replace the cluster. When replacing a defective Huntsville cluster, remove the mileage chip and place it in the new cluster to retain the vehicle's mileage. If the chip has failed, you may order a new mileage chip with the actual vehicle mileage from Huntsville. As an alternative, install a zero mileage chip, then note the previous vehicle mileage by affixing a label to the left door frame. When installing a new programmed mileage chip from Huntsville or a new zero mileage chip, the cluster will display an asterisk. Both clusters have a built-in 9.5 volt minimum operating limit. If system voltage drops below 9.5 volts, the cluster will go blank. The Motorola diagnostics tests the cluster in a similar fashion to the Huntsville cluster. Motorola's diagnostics, however, also tests the oil pressure sending unit, the fuel level sensor, and wiring. It also checks the engine temperature circuit for shorts to ground, but can't detect an open. New clusters or clusters sent back repaired must have vehicle mileage entered by these buttons. Refer to the work order for correct vehicle mileage. Only 3 programming attempts are allowed, and the change is noted by an asterisk. No mileage changes can be made after 10 vehicle-driven miles have been accumulated. Another important difference is that the tachometer signal on the Motorola unit is the basis for the oil pressure gauge. If the tach input fails, the oil pressure gauge would falsely drop to zero pressure. If the engine light does not go on, there's proper oil pressure. If this condition exists, the tach input wiring should be checked. When servicing the cluster, an accurate description is essential to quick diagnosis. In this case, the technician would concentrate on oil pressure. To enter the cluster's self-diagnostics, press both the trip and trip reset buttons as the ignition is switched on. Wait for check to appear in the odometer before you release both buttons. To begin the diagnosis, press the US metric button. Fail appears in the odometer, indicating an open in the oil pressure sending unit, wiring, or the cluster. The next step is to unplug the connector to the oil pressure sending unit. This oil pressure switch is nearby. Be sure to test the correct unit. Ground the sending unit wire and start the engine. If the gauge jumps too high, the wiring and the cluster are okay. With the engine off, remove the oil pressure sending unit and install an engine oil pressure gauge. If oil pressure is within normal limits, replace the sending unit. If the problem is inaccurate speed, odometer, and Traveler or Navigator information, and the cluster's diagnostics are okay, check the distance sensor. After calibrating the ohmmeter to 0 resistance, connect it to the sensor. Very slowly rotate the shaft once and count the pulses. 8 distinct pulses below 0.5 ohm indicate a normal sensor. The following are examples of defective sensors. The sensor reads above 0.5 ohm. This sensor has less than 8 pulses. A shorted sensor will read 0 resistance. An open sensor will read infinity. Proper distance sensor installation requires this bolt head to locate within the sensor body's notch. This prevents sensor rotation. You see, electronic instrument cluster problems seldom trace to a faulty cluster. A systematic approach is the fastest way to discover the real cause. It's the same way with radio diagnosis. The fastest way to solve radio problems is to use common sense and gather accurate information from the customer. Is the trouble with AM, FM, or with the tape player? Do you hear static, noise, or just poor reception? Do you notice the noise at the lowest volume setting or at normal listening levels? Does the problem occur when the ignition switch is in the accessory or on position, or with the engine running? Does the noise occur when other electrical components are turned on? The most common complaint is radio noise. Noise is either radiated or conducted. Radiated noise is produced when an accessory device, such as the heater blower motor, gives off a radio noise signal that is picked up by the antenna, along with the desired signal, amplified and fed to the speakers. Other possible noise sources include the wiper motor, the radiator fan motor, the Navigator, the automatic temperature control motor, the automatic temperature control electronics, the electronic instrument cluster, the logic module, the electronic spark advance module, the overhead compass, and the electric fuel pump. Radiated noise is heard best outside, away from large power lines and on weak AM or FM stations at normal volume. Conducted noise, however, travels through the component power feeds into the radio circuitry and is most noticeable at the lowest volume control setting. Possible sources of conducted noise include the alternator, the power module, and the opera lamps on the New Yorker. These are effectively suppressed by installing an inline choke in the radio ignition power feed. If noise is heard only at the lowest volume control setting, the source is conducted. To further differentiate between radiated and conducted noise, pull the antenna lead from the radio. If the noise ceases, its source is radiated. Set the ignition switch in the accessory position. Switch on the radio. A possible AM noise source is the overhead compass. Isolate the compass by removing the number 10 fuse. The Navigator may cause FM radiated noise. Again, with the ignition in the accessory position, press the time button. Listen for static or hash through the radio. Consult the Technical Service Bulletin number 080785 for specific details to repair this condition. But before you remove the radio, check the ground straps from the radio to the instrument panel, from the engine block to the dash panel, and the engine mount clip-on strap. Be sure the antenna mount is tight and the antenna lead is fully seated in the radio jack. In some cases, the problem may actually be a defective radio. If the radio noise is not present in the accessory position, then switch the ignition to the on position. Disconnect the connectors to the logic module to isolate it as a possible noise source. If the noise still exists, reconnect the logic module and disconnect the power module. If the power module produces conducted noise only with the ultimate sound radio, the radio may be defective. Also, on carbureted vehicles, disconnect the electronic spark advance module to isolate it. If either the logic module or the electronic spark advance module has caused the radiated noise problem, then contact the zone technical advisor to procure a special replacement module. In addition, cluster noise can be easily isolated by removing the cluster power fuse. The number 4 fuse will isolate the automatic temperature control aspirator motor and heater blower motor. The number 2 fuse will isolate the automatic temperature control electronics. The wiper motor may also be a possible noise source. Occasionally, radio output is muted when a door is open, even though the electronic voice alert system has been deactivated. Drive the car with the door ajar and listen for a muting effect. Remove the voice alert fuse and repeat the test. If this solves the muting problem, then use the service manual procedures to repair the wiring or replace the faulty voice alert module. Start the engine. Radio noise that increases with engine RPM is either conducted alternator whine or radiated noise from a faulty ignition system. Ultimate sound system complaints may occur when functions are improperly adjusted or switched off. Switch on the equalizer and set the controls level at the midpoint. Set the ambience level to its lowest position. Switch on the stereo reception control. And if the complaint is a non-functional clock, restart it using the owner's manual. It can be switched off. If the clock or radio memory keeps resetting or goes completely blank, try the lighter. It's on the same circuit as the clock's memory feed. If it won't work, this indicates a faulty memory feed circuit, defective lighter, or a blown fuse. If a channel or speaker is not functioning, substitute a good speaker. This will confirm a faulty speaker. Test the speaker wiring. If the speakers and wiring are okay, the radio is defective. If the customer complaint is poor FM and/or no or noisy AM reception, check the antenna. The mount may be loose. The antenna cable may be shorted to ground or have an open. The antenna pigtail on Lancer or LeBaron GTS vehicles may be loose. Or the plug may not be firmly seated in the radio jack. A simple test with a quick magnetic mount antenna will indicate whether or not the antenna is defective. If the vehicle is equipped with an overhead compass, do not mount the test antenna on the roof. The roof will be magnetized, permanently altering compass accuracy. If all attempts fail to solve the noise problem, connect a radio of known quality. It's acceptable to substitute a different type of radio. When installing any radio, be absolutely certain to connect the 12-volt battery feed to its connector and not to the radio's speaker output connector. If the substitute radio provides noise-free reception, then the original radio may now be sent in for repair. Troubleshooting the Navigator and the Traveler is made easier through the use of self-diagnostics. The Navigator is arranged in 2 configurations. This version has 2 different faces: chrome for the 1984 and 85 New Yorker, black for the 1984, 1985, and 86 Daytona, and laser. This configuration applies to the 1985 and 86 Lancer and LeBaron GTS. The Traveler mounts where a tachometer would normally be on the 1984 and 85 New Yorker. The Navigator and the Traveler use vacuum fluorescent displays and system diagnostics. The Traveler uses 2 buttons to display 5 groups of information here. The Navigator uses 12 buttons to display 9 groups of information here. Both units use information provided by the distance sensor, the fuel tank sending unit, and for 1986, a fuel flow signal from the logic module. The 1984 and 85 New Yorker use a fuel flow sensor. To enter the diagnostics, press and hold the step and US metric buttons, then start the engine. Release the buttons. The entire cluster will illuminate, but concentrate on the traveler. To test the distance sensor, just press the step button. The display should show A0. While the vehicle is moving, the display should read the speedometer reading plus about 10%. When the vehicle is moving and the speedometer reads, for example, 25 and the traveler reads 0, check the wire for continuity between pin 13 of the black 21-way connector and pin 4 of the blue 13-way connector. If you do not have continuity, repair the open in the wiring. If you do have continuity, replace the cluster. If the cluster and the traveler both show 0, check the distance sensor and wiring as outlined earlier. If the sensor and wiring are okay, replace the cluster. To check the fuel flow signal, press the step button. The display should show between B2 and 6. If the display shows B0, check the logic module's light blue wire. At connector 1, pin 14. A steady 0 or 5 volts indicates a faulty logic module. A fluctuating reading above 0 and below 5 volts indicates faulty wiring to the cluster or a faulty cluster. To test the fuel tank sending unit, press the step button again. This display should show C and some number. Divide this number by 8 to get the number of gallons in the tank and check the answer against the fuel gauge. They should compare. If they're different, test the fuel gauge with the cluster's diagnostics as outlined earlier. If the cluster gauge is okay, then check the wiring from the sending unit to the cluster for faults. Use service manual procedures to test the sending unit. Check the tank for damage. If the sending unit is okay, ground the sending unit wiring. Wait 30 seconds, or switch the ignition off, then on, for the gauge to respond to full. If the traveler computes less than a full tank, or if the cluster's fuel gauge reads less than full, but the traveler indicates a full tank, check the wiring between pin 2 of the 13-way connector and pin 16 of the 21-way connector for continuity. If the wiring is okay, replace the cluster. To test the traveler's calibration, press step. D3 should appear in the display, indicating a 14-gallon tank. Press step to exit the diagnostics. Diagnosis of the Navigator is similar to the Traveler, but there are distinct differences. Begin with an accurate description. If the Navigator and the cluster aren't displaying accurate information, begin by checking the distance sensor signal. To enter the Navigator's diagnostics, switch the ignition on, press the speed button, then press the US metric and reset buttons. Now press the set button. Enter 122 in the upper left portion of the display by pressing the buttons with digits. If, after a road test, you find that both the speedometer and Navigator readouts are obviously not correct, check the wiring and distance sensor as explained earlier. Incorrect range, fuel, and economy functions indicate a rate of fuel usage problem. Enter the diagnostics and punch 123 into the display. At idle, the display should show a number between 2 and 6 in the lower right portion of the display. If the display reads 0, check the logic module output at connector 1, pin 14, as explained earlier. Next, check the wiring for continuity from the logic module to the Navigator's pin number 6 connection. If the wiring is okay, replace the Navigator. If the work order points to an abnormal range function, enter the Navigator's diagnostics and input 124 into the display. With a full tank, the Navigator readout should be 30 or less. The cluster's fuel gauge should also read full. With an empty tank, the Navigator should display 229 or more. The fuel gauge should, accordingly, show a very low level. With a 5-gallon fill, the Navigator should display about 185, and the gauge should show less than half full. These are normal conditions. If the gauge, the Navigator, or both display other than normal, test by grounding the fuel level sending unit wire. Wait 1 minute. If the gauge reads full and the Navigator reads 31 or more, the Navigator or wiring from the cluster to the Navigator is defective. If the Navigator reads 30 or less and the fuel gauge reads below full, check the cluster's diagnostics. It may be defective. If both units show less than a full tank, the sending unit wiring is faulty. If the cluster shows a full tank and the Navigator displays 30 or less, the cluster and Navigator are okay. Use service manual procedures to check the sending unit for accuracy. Troubleshooting electronic instrument clusters, tracking down radio problems, and solving problems with the Traveler and Navigator are all easier with the help of their system diagnostics and a complete proven plan of action to repair things right the first time.